So the next function we want to look at is logarithms. Logarithms are the inverse of exponential, or should I say the opposites. So where you have a function that grows really fast, logs, the opposite of growing fast, logs grow really, really slow. And then likewise, our exponential functions, which has a horizontal asymptote, logs, you see here in the green, have a vertical asymptote. They'll try to get really close to the y0 or y-axis, but they'll never touch it or reach it. They have a vertical asymptote. One of the main parts of this unit with logs is to be able to convert between a log function and an exponential. So as we look here, our y equals log base b of x. Its conversion is where the base of my log is the base of my exponent. My log equals the exponent of my base. And my log base of this x, that is what my exponent equals. So as long as you have this conversion here, just match up the numbers. Again, remember logs will equal your exponent. So I want to convert 2 equals log base 4 of 16 into an exponent. First, what is my base? My base for my log here is 4. So I have a base 4. Next, my y. What is my exponent? My log equals the exponent, so my exponent is 2. And that equals the x value of my log. Does it not make sense that 4 squared is 16? Now what if you want to go the other direction? 2 to the 4th power equals 16. I want to convert this to a log. What does my log equal? My log equals my exponent, in this case 4. So 4 equals log base of what kind of base is a log? Well, the base is the same base as your exponent, so 2. Log base 2 of 16. So as long as you have this formula with you, just match up the letters and what they correspond. That is your conversion. Log base 2 of 16 equals 4. Again, log equals your exponent. That is vital because that helps us evaluate logs when it may seem impossible to do so. Looking here, log base 12 of x equals 2. What value of x makes this true? Well, there's no way I can plug this into the calculator because of this variable, so let me try to convert it. So my base is the base of my exponent, which is raised to the power that my log equals, so 12 squared equals x. This I can do because I see it equals my variable. What is 12 squared? That is 144x. So log base 12 of 144 equals 2. What if you have an exponent you can't solve? Well, let's try to convert it to log because I don't know what value for x will make this 64 equal 8. Let's look at a log. So log base of 64, same base as our exponent, of 8, what my exponent equals, again, your log equals that exponent. So log base 64 of 8 equals x. Now I have something equal to x that I can calculate. So how do you calculate a log with a base of 64 and not a base of 10? Note you can't just do log in your normal calculator because that is log base 10. What you need to do is find your log base in one of these fancy calculators. I can either go alpha window, I see log base, or I can click on math and go all the way down to, log base. What this does, it allows me to enter in whatever base I want. So log base 64 of 8, and I see it's 0.5. So x equals roughly 1/2. Well, not roughly, it does equal 1/2. So 64 to the 1/2 power will equal 8. So those that don't have a fancy calculator, all you have is log base of 10. What you can do is what's called change of base. So I want log base of 10, and I'm going to use my log here 8, and I'm going to divide that by log base of 10 of what my base is, 64. There. So this is called change of base. If you only have log base 10, what you can do is divide the number here by your base of your log. That should give you the same answer. Speaking of log base 10, that is what's called common log. So if you don't see a base, remember math, they're pretty lazy. If something's used very commonly, they usually just take it out altogether. Too lazy to write it. So this is assumed to be a base of 10 if you don't see a number here. If you do see a number here, that will be your base. Otherwise, it's assumed to be a 10. Some other properties of logs is if your log value here is a 1, then your log is always going to equal 0. Well, why does that work? Well, let's convert this to an exponent. So I have my base b to the 0 power. Is anything to the 0 power 1? Sure is. That's why log base of a number 1 here is always going to be 0, because your exponent with a 0 power is always going to be 1. Likewise, if your log is the same as the base, it is going to be equal to 1. Now, how does that work? Again, I have my base b here, raised to the 1 power. Anything to the 1 power is the same number, in this case, b. So that's why if you have your log the same as your base, that will equal to 1. And then lastly, if you happen to see your base raised to the same exponent, that's going to equal the exponent. Well, why does that work? Well, again, let's convert it. So I have a base b raised to the x power equals, does that not make sense that it equals to x? It sure does. So if I see something like log base 4 of 4 cubed, well, that equals 3. Our cubed, it equals our exponents. Because what happens is these two will cancel out.